Today we're going to get a little more in depth with our sequences and talk about first different positions in a sequence. So if I'm asking you to find f of 4, this is saying I want the fourth term in the sequence. So this is my first term, this is my second term, third term, fourth term. So f of 4 is going to equal 14. We talked a little bit about the fact that the domain of a sequence is the natural numbers. So these are essentially our x values, and these are essentially our f of x values. So if I want to find f of 7, let's see, this one is 5, this one is 6. I need to know the next blank. So I'm going to look at it and I'm going to say first, I've got to figure out what my pattern is. How do I get from 5 to 8? If I'm not sure, I would say 8 subtract 5, which is 3. So I'm adding 3 every time to get there. So my next term, if I add 3 here, would be 23. Let's look at another one that's similar to this. Okay, so I've got my first term is -3. This one is asking me first for my second term. This is my second term, so f of 2 is going to equal 1. Next, it's asking me for my seventh term. So I'm going to go 3, 4, 5, 6, and again, I need the seventh one, which is the one that's not there, of course. And so I need to find my pattern again. So I'm going to look right here, and I'm going to ask myself, how do I get from one number to the next? Well, when I'm dealing with positives and numbers, I'm a little unsure, so I'm going to take my second term, and I'm going to subtract my first term, which is a -3. 1 subtract -3 is the same as 1 plus 3, so that would be 4. Hey, if I check that here, because sometimes I'm not really sure if I got the right thing. Am I adding 4? Is 1 plus 4?
Mr. Neal, Tyrell Neal, if you're back in the building, would you come to the office? We have some time to visit with you. Thanks.
Sorry about that. So 1 plus 4 is 5, 5 plus 4 is 9, so I do have the right pattern. So now I'm going to say 17 plus 4, which is 21. Okay, now it says 86, and it's not a typo. I'm not asking you for the 8th one and the 6th one. I really want 86. Well, that's really hard to find. In order to do that, I'm going to need to find my explicit function, which is what we've been doing for the last few days. F of x equals my constant difference plus my 0th term. Let me move this over a little bit to give me a little bit more space. I'm going to do a little erasing up here. So I have the space I need to make this work. I already figured out that this is going up by 4, so I know that my constant ratio is 4. What I need is my 0th term. So remember, the 0th term is not a part of the sequence, but it's kind of like a y-intercept. It's saying, hey, if I had a 0 number following my pattern, 0, 1, 2, 3, 4, what would the number be here? Well, if I'm adding 4 going this way, I would subtract 4 going backwards. So -3 minus 4 is -7. So I'm going to put my -7 there. How do I figure out the 86 term? I still haven't got there yet, have I? I'm going to say 4 times, this is my x, so I'm going to plug in 86, and then plus a -7, or you could just write subtract 7. Your choice. Type that in your calculator, and you will get 337. That's the nice thing about those explicit functions, is that you can get numbers that are far away. Okay. Sorry, I did that on the other page. But what does the word recur mean? Recur means, according to the definition, it occurs again, or it, and I like this one right here, it repeats. Okay, so we're going to talk about a recursive function. That's our whole goal today, is to get a recursive function. That means it's a function that's telling us what is repeating. So the first thing I want us to do is look at this and say, how would you describe the pattern? Now I'm guessing if I were to ask you to do this, you would say add 3, because that's what almost everybody does. They say add 3. Okay, so now what I want you to do is I want you to tell me, can you think of another pattern that is saying add 3? Okay, so I could think of this one. 1, 4, 7, 10. That's one pattern. It's adding 3 every time, but it's not the same as the one I gave you. Another one would be -12, -9, -6. That's also adding 3. Hey, another one is 100, 103, 106. Okay, so I can come up and I can keep going. I can make an infinite amount of patterns that add 3 every time, or sequences that add 3, but they're not the same one. So how do I tell somebody that it's the same, or I want you to come up with this pattern? If we were playing a game and I wanted you to guess my sequence, you would not be able to guess it unless you told me where it starts. You've got to tell me, hey, 7's the first number. If I tell you to start with 7, and then I told you we're adding 3, you would be able to figure out what the pattern is, because you would say, oh, 7, then I'm going to add 3, then I'm going to add 3, and keep going. But if I don't tell you where to start, you're not going to be able to figure that out. So what is that telling us? We want to look at this thing and we want to describe it in our words. Hey, 2 things. Starts with 7 and it adds 3 every time. So when you describe these, you have to give me 2 descriptions. Now we're going to turn that into math. What does this look like? Because we're coming up with, again, I mentioned this a minute ago, but the word recur means a pattern or a repeat. I need a function that tells me what is repeating. How do I write the first number is 7? In math language, just like we were doing at the beginning, I would say the first number. Hey, x, my first term, is going to be 7. F of 1 equals 7. Now the next part is a little bit tricky, and I'll explain it, don't worry, but it's going to look really weird at the beginning. And most people get really hung up on what it looks like, but then they figure out that it's probably one of the easiest formulas we do because it never changes. You just have to memorize it. So this is what it looks like. To say that we're adding 3 every time, what we're going to say is if I want to find a number, that's what that means. If I want to find anything, if I want to find f of 1, or if I want to find f of 2, or f of 3, or f of 4, I'm going to take the one before it. Okay, that looks weird, but it's saying, hey, if I want to find f of 4, I'm going to take, what's 4 minus 1? 3. And I'm going to, in this case, it's add 3. I'm going to add 3. So this is saying, I take, if I want what I want, I'm going to take the one before it plus 3. Okay? It looks weird, but that's what the formula is going to be, and it will never, ever, ever change. Even when we do multiplication, it's not going to change. Okay, so just kind of showing you once again, the first term is f of 1, 7 is right there. F of x means whatever term we're looking for. F of x minus 1 means the term before it, and then we just add on what is our pattern. Let's look at a different one. We're going to take it from our verbal description here, so what we can start with, and then we're going to translate it into the recursive function. Again, the word recur means repeat. It's telling us what is the pattern. So first I need to look up here, and the question asks me, the first number is, there it is, it's 1. And then what am I adding every time? Well, from 1 to 7, let's say I don't know what that is. 7 minus 1 is 6. Okay, so I'm adding 6 every time. So what does that look like in my function? First, I would say f of 1 equals 1. And then I'm going to say, if I want to find a number, I'm going to take the 1 before it, and I am going to add 6. So the 1 before it adds 6. I'm going to try to explain again because I know that most of you probably right now on that part right there are a little hung up. Let's just look at it. How does it work? This is what it says. If I want to find f of 6, okay, so right here, f of 6, what I'm going to do, and I'm just going to take this section right here because my first term isn't going to change. F of 1 equals 1. It says, let's say I want f of 6. I'm going to take f of, hey, 6 minus 1 is 5. And then I'm going to add 6. Well, what is f of 5? 25 plus 6 is equal to 31. Now, do I expect you to write that out and do it every time? Absolutely not. What I'm doing is I'm showing you, why does this weird formula right here, okay, it does look weird, I get it, why does it work? It's saying, all this is saying is f of x is whatever number you want, take the 1 before it and add 6. Okay, let's look at this one right here. It would be a good idea for you to pause the video and try it, see if you could figure it out. And then you can unpause it and we'll do it together. So we're going to start with our first term. Hey, it's 5. Then we're going to, hey, what are we adding every time? Well, 8 minus 5 is 3. So that means 5 plus 3 is 8. Here we go. So I am adding 3 every time. Looking at my formula. F of 1, that means my first term is 5. And then I'm taking any term. I take the 1 before it, and I add 3. Okay, go ahead, and I'm actually going to pause this. Okay, we're going to look again at the why it works, because I just want to make sure that you kind of get a grasp of why is this function, even though it looks weird, why is it working, and what's the difference between it and the explicit function. So if we're looking at this, it says, hey, we want to find f of 7. So if I put that in here, I'm going to say find f of 7. But right here it's asking me, I need 7 minus 1, which is 6. Hopefully you were saying that in your head. Plus 3. So I look up at my chart and, hey, I don't have 6. So in order to get f of 7, I have to have f of 6. That's kind of the limitation of a recursive function. The only way this function works is if you know the number before it. So before we can ever get it, we have to find f of 6. So in order to get f of 6, I would take f of 5 and I would add 3. Well, 17 is f of 5 plus 3 is going to give me 20. Now that I've got 20, I can do the same thing to get f of 7. So now I can take my f of 6, which I do know, and I've got f of, let's see, sorry, I did f of 6 again, didn't I? F of 7 equals f of 6 plus 3. Well, now I know that f of 6 is 20, and when I add 3 to that, I get 23. Okay, so that's just kind of how is this weird function working. Are you ever going to have to explain it to me? Probably not. As long as you can memorize it, you're going to be golden. Okay, so let's look at this one. We're going to practice again. I didn't give you the function to fill in the blank. We'll work on that in a minute. Okay, the first number is, there it is, -3. Add what every time? Ooh, negatives are not my strong suit. So I'm going to actually type in my calculator. -1, which is my second term, subtract my first term, which is -3. Okay, -1 subtract 3 is going to be 2. Let's check it because I'm always a little bit weird about negatives. Does that actually work? Is -1 plus 2 1? Is 1 plus 2 3? Is 3 plus 2 5? Hey, yeah, it is. Okay, so once I check it, I know that I can move on. So how do I write this first part? F of 1, that tells me I'm looking for my first term, or I know my first term, is -3. Where does my sequence start? It starts at -3. Now I'm going to say f of x equals f of x minus 1, and then it was adding 2. If I want a term, I take the 1 before it, and I add 2. Okay, here is the next one. We're gonna move on. Okay, so here we go. Now we're gonna do both explicit and recursive functions because you're gonna be responsible for both of them. So if I look at this function, I can really start anywhere, but do you know where I always start? Because it's the easiest for me anyway. I start with the first term. Hey, all I have to do is look, and there's my first term. It is 3. The next thing I say is, what is my pattern? How am I getting from 3 to 10? If you're not sure, you do 10 minus 3. that gives you 7. So I know that because it was a positive 7 means I'm adding 7. And go ahead and check it. Is it adding 7? Yep, it is. Now, if you look, that's your constant difference. It goes here, but it's also in your explicit function that we've been already studying. It goes right there. So the only thing I need to find still is I need to find my 0th term. Okay, that's the one before it that doesn't really belong in your sequence. So if I added 7 to go this way, to go backwards, I'm going to subtract 7. So 3 minus 7 is -4. Okay, let's try another. Wait, you know what? No, we'll do it on the next one. Okay, let's do this one. Now, I didn't label anything this time. We're going to hope that we can remember some of these things. F of 1, what is my first term? That's where I like to start, right here. Hey, it's 8. Next thing I like to look for is my constant difference because I can fill it into both formulas. How do I get from 8 to 17? If I'm not sure, I go 17 minus 8, and that is 9. Then I check it. Hey, am I adding 9? Yeah, I am. I put my 9 here in my recursive, and then that function's done, and then I put my 9 here. Now I'm left with one more fill in the blank. I need my 0th term, which goes right here. If I added 9 to go that way, I'm going to subtract 9 to go backwards. So 8 minus 9 is -1. That is -1. This time I'm going to show you one more thing that you can do because you can check your explicit functions to make sure they're right. We've talked about this probably in class already, but in case you missed it, pick one. I'm going to pick my 3rd term. If I want to check it, I'm going to say f of 3 is equal to 9 times 3, I'm just using this formula right here, plus a -1. And then I would type that in my calculator, we'll figure it in my head. 27 minus 1 is 26. You could test it with another one too. It doesn't hurt to test it with a couple, but odds are if you're getting at least one number that isn't your first term, you probably did a pretty good job. Okay, next one. This time I didn't give you any functions. We're going to fill in the whole thing. Okay, so I'm going to start with what I think is the easiest part. F of 1 is equal to 3. My first term is 3. Now I'm going to write down the part of this function that I know. F of x is equal to f of x minus 1. Now I need to figure out my pattern. I have a hard time with patterns when they're positives and negatives. So what I'm going to do is in my calculator say -5 subtract 3. -5 subtract 3 is -8. Test it. Is -5 minus 8 -13? Is -13 minus 8 -21? Yeah, all of those work out. So I'm going to put my -8 here. Now let's come over to the explicit. F of x is equal to -8x because that is my constant ratio or constant difference. And then I just need my 0th term. Well, if I did -8 going that way, I'm going to do +8 going that way. So 3 plus 8 is 11. Since it's 11, I'm going to put +11. Next one. We're going to do a hard one, a level 3 one. And this one you're going to have to use a calculator to help you out, unless you're really good at fractions. But most likely you're probably not as awesome at fractions. I wasn't. I used a calculator. Okay, so don't get scared of fractions because guess what? You have a calculator that does all this for you. First, can you get part of the recursive function? Absolutely. Look at this. F of 1 equals 2/3. Even though it's a fraction, I can still write down my first term. The next thing is I can write part of this formula. I just need to know what is my pattern. Honestly, I can't even tell if I'm going up and down because those numbers are so crazy. So I'm going to tell you what I would type in my calculator. You take the second number, you subtract the first. So I would just type in 11/12 minus 2/3. When I type that in my calculator, I'm going to get 1/4. That's telling me that I am adding 1/4. Okay, so that's my pattern. Now, it's always a good idea to check it, and you've got a calculator, so it's not that much work to just say, is 11/12 plus 1/4 going to give me 7/6? Is 7/6 plus 1/4 going to give me 17/12? So it's a good idea to check it, and I did check it before I did this, and I got that it was the right pattern, so I'm going to put my 1/4 there. Now we're going to come over here to the explicit function. f of x is equal to 1/4 x. I need that 0th term. And I know you're probably like, oh, more fractions. Yeah, you can do it. If I add 1/4 to go that way, I'm going to subtract 1/4 to go backwards. What would you type in your calculator? You would type 2/3 subtract 1/4. Okay, and when you do 2/3 minus 1/4, you are going to get 5/12. It's a positive 5/12, so we're going to put 5/12. Okay, that is probably as far as we're going to go today. That's as hard as it is. Hopefully this video helped you and that you can work through your recursive functions. Bye.